Okay, we're going to briefly look at for your lesson today. I'm just going to kind of get you a head start by going over the periodic table. Now, there are many different representations of the periodic table. Some are black and white, some are in color, some contain more information than others. This is a pretty nice one. I like them being in color here. And this periodic table is very similar to the one that was created by Mendeleev that in your studies that you've been reading about. So we're just briefly going to go through. You can see here, see this little number in the upper left-hand corner? There, 1, 2, 3, 4, 5, 6, 7. Those are the atomic numbers. Okay, and so what the atomic number tells you is, remember, inside the nucleus of an element, there are protons and neutrons. And then around the outside of the nucleus, we have the electrons that are revolving around in different shells or rings around the nucleus. So this number here, that atomic number, like the 1, 2, or the 32 here, or the 6 here, is the atomic number. And what the atomic number tells you is how many protons are within the nucleus of one atom of that element. Now, what's nice about this one, this particular table, the way it's made up, is that it has see the letters here. Not only does it has the representation, the chemical symbol for it, like boron is B, nitrogen is N. What's nice about this one, and not all of them have it, if you look down here underneath, it actually tells you what the element is. Here's Al for aluminum. There it says aluminum, but the representation of it, the chemical symbol, would be Al. Beryllium, Be, and you can see it right underneath. So far we've looked at the atomic numbers that are in this one are up in the top left-hand corner. And we've looked at the chemical symbol for each one of the elements. Okay, and this would kind of this is kind of nice here. If you look at this, it tells you what each square actually represents. There's an atomic number in the upper left-hand corner, like we were already talking about. There's a symbol, which is the H, or the Li, or the C, or the oxygen. They also talked about on this particular periodic table, they actually have the name of the element, which is really, really nice too. Now, right below here, you'll notice that 1.00794, they also have the atomic weights. Now, we're going to do it very simple here. What I'm going to have you do is we just round this atomic weight. We're not going to talk about isotopes or anything right now. But if you round this off, like here's 12.0107, it would round off to the nearest whole number would be 12. So we're going to say that the atomic weight of carbon, for one atom would be 12. Now, remember here we said that the atomic number up here tell us how many protons are in the nucleus. And most of the mass, most of the material in any atom comes from the protons and neutrons inside the nucleus. The electrons are so small that they don't even really count them as far as adding into the total mass of an atom. So if we take the atomic weight here and round it off, like to be 12 here for carbon, and I take 12, take away the 6, which is a number of protons, that'll tell you how many neutrons there are. So in this particular atom of carbon, there are 6 protons. The atomic weight was 12. 12 take away the 6 is 6. So this one atom of carbon has 6 neutrons in the nucleus. So there's quite a bit of information, as you can see as we go through this, to be obtained from a periodic table. Let's see. Now when you look in your lesson, your periodic table is going to look a little bit different than this. Like I said, there's many different drawings and that people have made. With some have black and white, some have colors, some have descriptions. Some tell, like this here, what every little symbol means in each box. So I don't think yours has quite as much information as you're seeing here, but that's okay. You can still use it to determine a lot of things. Now, the next thing that we want to talk about, we actually have, do you see up here the 1A, 2A, and then it comes over 3A, 4A, 5A, 6A, 7, those are Roman numerals. I don't know if you're familiar with them, but like the V is a 5. The V with a 1 on the right represents a 6. The V plus 2 would be 5 plus 2, which is 7. Okay, V plus 3 would be 5 plus 3 is 8. Those are what we call the groups. Okay, so this is a group coming down here. That's group 1. This would be considered group 2. Then you notice that we jump way over to here. All of these in the middle are kind of like intermediary type of elements. Okay, so they have some different things that go on with them, which you could learn certainly at a different time. Here's group 3. So that's group 3. All these elements are in group 3. If we were to look over here, here's all the elements in group 8. So we want you to know what the what the groups are. And then if you look across here, you go straight across, you can tell we can either categorize them up and down vertically, and we call them groups. We can also say that, look at all the elements in this row here. And these rows, this one, or this one, or this one, which only has 2 up here, those are called periods. And the way that I remember in my mind the difference between a group and a period and which one is which is that I know that a sentence, goes along like this, and at the end of a sentence you have a period. So that helps me remember that this direction, the horizontal, are the periods, and the vertical up and down, which would have to be the other one, which are the groups. Now you can tell if you look here, they have them. There's 2 families that they designate on the periodic table, either metals or nonmetals. Now what I like about this one is that, since it's color coded, all of the ones that are these colors here are what we consider metals. So like this would be a metal. This is considered to be a metal. This is considered to be a metal. Then we have the non-metals, and as you can tell, there's the are designated by color too. So this, the green, this real pretty kind of blue-green color here would be a non-metal. These noble gases are also considered non-metals. So they kind of break them down into to the best of their ability, metals versus non-metals. Obviously, we have some metalloids here that are kind of in the interim between the metals and the non-metals. Now, I think in your lesson they just consider them to be they only talk about the 2 major families, and obviously the 2 major families would be the metals and the non-metals. Now, the metals are, each one, the reason that they break them down into those families, separate those elements out, is that there are some differences between them. And the metals, these are the elements that are usually shiny, and they conduct electricity, and they can warm up. Now some metals are soft, they can be kind of hammered into various shapes, while others are more brittle. So if you snap them, you can break them into pieces. Now all metals are solid except for one at room temperature, and let's see if we can tell here. All of these metals here, remember the ones that are metals, but look down here, this Hg, that's a liquid. So at room temperature, it's kind of nice on this particular chart, even shows you the one metal that is not a solid at room temperature, and it's the mercury here. Now non-metal, let's go over to the non-metal over here, are elements that don't have the properties of metals. So nonmetals are poor conductors of electricity. Remember, the metals were good conductors of electricity, and the nonmetals are the poor conductors of electricity and heat. They're not shiny, they're not lustrous. Now those nonmetals, though, can be solids, they can be liquids, they can be gases, all of those at room temperature. So good examples would be the oxygen here. We know that's a gas at room temperature. Okay, carbon is a solid at room temperature. Okay, so let's see, what else do we need to talk about here? We've talked about the grouping, we've talked about the periods. Remember, we talked about the groups, that there are 8 of them. You go from 1, 2, over here to 3. Remember, these are the ones in the middle that are kind of, that they don't fit exactly into some of the categories, and so we're not putting them in any particular group there. Now, what's kind of interesting is that elements in a group, like whether it's this group here or this one or back over here, the elements that you see listed within a group here, like this one here, they all have similar chemical properties. So the fluorine would have similar chemical properties to the chlorine, which would have similar chemical properties to the bromine. Over here, the beryllium would have similar chemical properties to the magnesium and similar to the calcium. So any of the elements within a group have similar chemical properties. Now, what's kind of interesting about this particular group over here, the one on the far right, they're called the noble. I don't know if they say that here. The noble gases here, the helium and the neon and the argon, krypton. Krypton, remember, had something to do with Superman. So they have similar chemical properties, and the elements in this noble gas group are all gases under normal conditions here, all of these here, and they don't react with other elements. Okay, so you can see just going through that that's one of the things that these elements have in common with each other in that particular group. Now we've talked about periods here. Now it's kind of interesting if you look here. Let's look at this one here, this period here. Come up, you see these little numbers 2881. I like this periodic table because a lot of periodic tables don't have this, but this tells you how many electrons are in the first shell, how many electrons are in the second shell, how many electrons are in the third shell, and how many are in the fourth shell. Okay, so you can see that this particular potassium has 4 shells. What do you notice as we go across here in this particular period? Look at calcium has 4 shells. Iron, 4 shells. So when you look at 1, 2, 3, 4, this is the 4th period. That tells you that every element within that period has 4 shells of electrons. So that's kind of cool. Here we go down to 5, and sure enough, look at everyone in here, every element in here has 5 shells. Now, you notice a little sign right here, and it probably says, oh yeah, look at radioactive. See that little sign? That's kind of a common sign you even see in like hospitals and stuff. These are the radioactive elements down here. So you can see some down here too. So they have high atomic weights. The nucleus is very unstable, and the nucleus can break down by giving off energy and neutrons, and this energy can be very, very dangerous. So in handling any of these elements that you see that have that little radioactive sign on it, have to be handled very, very carefully because they can be very, very dangerous. Now, one thing I didn't mention is going back to the groups. Remember the 1, 2, 3, 4, all the way up to 7. You'll notice that the number here of the group actually, and let's just check it out to make sure it works, actually tells you how many electrons are in the outermost shell, remember, around the nucleus. So let's look at here, 7. This one, because there's a V11, remember that's 5 plus 2 is 7, because those 2 ones are on the right side. That means that you add it on to the Roman numeral 5. This one has 7, this one has 7, so that worked. How about here? 5, that outer shell, this element in this particular group has 5 in the outer shell. 5, 5. So you can tell by the Roman numeral in those groups how many electrons are in the outer shell. Now let's just pick one here. Here's nitrogen. Let's just look at that one here. What can we see from that? We can see that the atomic number is 7. That tells me that in the nucleus of one atom of nitrogen there are 7 protons. It also tells me that in a neutral atom the number of protons equals the number of electrons. So there are 7 electrons in the shells around the outside of the nucleus. Now it tells me, if I look over here, that there are 2 in the first shell, and remember we're in group 5, and 5 in the outermost shell. So we can see that. How many neutrons would there be in one atom of nitrogen? Well, let's look at the atomic weight. It's 14.00. Looks like 5, 7, so we round that off to the nearest whole number. That would be 14. 14 take away 7 is 7, so that tells me that one atom has 7 neutrons. As far as being in the period, it's in period 2, even though we've already looked at it. It tells me that what? There are 2 shells that have electrons in them. So there they are, 1, 2, so that verifies that. So I hope that helps a bit as you go through your lesson on the periodic table. And remember, your periodic table will look a little bit different, but if you ever need to get a different periodic table, or you want to get a different one that you want to run off, just Google it and pull up the images, and there's just multitudes of periodic tables that you could actually print off and just stick it in your binder so that you have it. Okay, you don't have to use the one that's right in your chart. So what I'd like to have you do when you finish watching this is go ahead and give me a call. We'll discuss it briefly. I'll ask just a couple questions, and remember, it's never a quiz. It's only to make sure that you understand what we talked about, what I talked about here, and then you can have credit for it. So give me a call, and I'll talk to you soon. Thanks for watching. Bye.